Good morning, everybody. So, in our today's module, we'll be discussing about the concept transformation of energy. Children, first of all, we should know that what exactly do we mean by the term transformation of energy, right? So, what is transformation of energy? One form of energy can be converted into other form of energy. Fine. Like for example, if I throw an object fine in downward direction, so the energy that is being changed here is from potential energy to kinetic energy. Fine. So when the energy is changing its form from one form to another, it is said to be the transformation of energy. Now children, like suppose when an object is dropped from height, let this be object, fine, that I'm making it with red color. So when an object is dropped from some height, its potential energy, because object is possess energy due to its position, this is what we call it as potential energy, right children? So what exactly happens here, that when an object is dropped from some height, its potential energy continuously converts into kinetic energy. Why? Because the object is in its motion right now. And when an object is thrown in upward direction, at that time what happens, bache? The kinetic energy continuously converts into potential energy. So this is what the concept is. Like for example, you know that everywhere there are green plants, they prepare their own food. I think you all have read this concept in your previous classes, right children? So that we call it as photosynthesis. So green plants prepare their own food that is basically stored in the form of chemical energy. Fine children? And how they are actually preparing their food? By using the solar energy. Fine. And that is through the process that is said to be photosynthesis. Similarly children, we can have one more example here. Like when we throw a ball, so what happens? There is a muscular energy that is present within us. Fine. So this muscular energy which is stored in our body, it gets converted into kinetic energy. So always remember this thing, that the muscular energy that we are having, we are utilizing this muscular energy to throw this ball. Fine. And then what happens? This object, that is the ball, possesses motion. Fine. It is in motion. That is why the energy is converted from muscular to kinetic. I hope it is clear. Similarly children, you can give many more examples related to this transformation of energy. Like one more example could be taken, like the wound spring. Yesterday I was discussing with you all the wound spring that is present in your watch. So it is also present in the toy car. Fine. So what happens, that this wound spring also possesses potential energy. Fine. Due to its position. Now what happens students, as the spring is released, its potential energy changes into kinetic energy. Now what happens, due to which the toy car moves? Like in your childhood, when your birthday comes, your parents bought a very good toy car for all of you. Fine. Like especially boys likes toy cars and all. So how does this toy car moves? Due to this wound spring that is present inside this toy car. Fine children. Okay, so one more example could be taken here. Like you can see in a stretched bow, what happens if we are stretching a bow? You might have seen the in Olympics games and all that people are playing the archeries. Fine. So what happens in this case? In this stretched bow, like for example, I'm making it for you. Like this is the stretched bow. Fine. And here comes the archery. Then you finally release this complete archery to your target. Now what happens in this case children? As it is released, the potential energy of the stretched bow. Why? Because when we are actually stretching the bow, so the energy that is possessed by this very object is said to be the potential energy. Right children? Because it is due to the position. Now what happens? The moment we remove this thing, fine, or we release this thing, so what happens? This complete kinetic potential energy is being changed up into the kinetic energy. Why? Because now your object is moving in a forward direction, that is too with a larger velocity. Fine children. See now, there are some basic energy transformation. I think you all are aware about these basic transformation. At your home also you are using number of equipments. Fine. Like for example, if I'll consider electric motor, so can you tell me which is the transformation, which energy is being transformed here? I think you all know what happens, children, that in electric motor we plug that switch, fine, into the electric board and we just on it. Now what happens? This complete electrical energy gets changed into the mechanical energy. Now what is mechanical energy? It could be in any of the form. Like for example, it could be in potential form, it could be in its kinetic form, right? Similarly, there is a this instrument that is said to be the electric generator. Now what happens, children? In this electrical generator, the opposite of electric motor happens. Like in we had discussed about electric motors, in which the electrical energy is changing into mechanical energy, fine. But when we are discussing about the electrical generator, so here what happens? The mechanical energy is converting into electrical, fine. And in your 10th standard, you will be studying about the concept of electrical generator in physics, where the complete machinery runs, fine. It produces the mechanical energy and ultimately it changes its mechanical energy to the electrical energy, fine, children. Okay, so now it's your homework. You need to know number of instrument. You need to tell me at least the list of 5 instruments, fine, and you need to tell me which energy is being transformed there, fine. Okay, so similarly it can happen with the steam engine, electric bulb, dry cell, solar cell. Like in steam engine, heat energy is converted into kinetic energy. Talking about electric bulb, so here the electrical energy is converted into light energy, and dry cell, chemical energy is converted into electrical energy, fine. And the last one we are having is solar cell, where the light energy is converted into electrical energy. So this was the transformation, children. Now let's just quickly come on to another topic that we have is the concept of power, which is very interesting, fine. Like you might have seen Chota Bheem, na? He eats lot of laddus and then he at that time, after having lot of laddus, his body possesses lot of energy, fine, so that he can quickly do lot of work. Similarly, when you become tired, your mother gives you food, fine, to eat, or you may demand the Glucon-D water in order to retain your energy, fine, children. So what happens? First of all, we should know that what exactly do we mean by the term power. Okay, so what is power? Power is the rate of doing work, fine, that is said to be the power. What is power? Basically, in which time, within a complete time period, how much work you are doing. Okay, that is what your power is. Like if you are able to do the work, fine, in lesser time, so it means your power is more in comparison to the person who is unable to do so. Children, first of all, we should know that what exactly the SI unit for power is, fine. So this thing I have already told you in my previous modules, that power is work done upon time, fine, children. So here the SI unit of power becomes watt. And you know what? James Watt has given this term, that is WATT, watt, fine. Remember this thing, the symbol that we are using here is W, okay. And see, every unit is expressed in the larger form, in the larger rate of energy. So here, when we are talking about the power, what happens, bache? We express the larger rate of energy, that is transfer in its kilowatt. So kilowatt is nothing but a larger unit of watt. Remember this thing, fine. Now see, here comes an important things. This could come in your examination in 1 mark MCQ form, okay. So like for example, we should know, bache, that 1 watt is equals to how many joule seconds, 1 kilowatt is equals to how many watt, fine. 1 horsepower is equals to how many watt. So what happens? 1 watt is equals to 1 joule per second, or we can say that 1 kilowatt is equals to 1000 watts. So suppose if this comes in your examination, तो आपने क्या करना है बच्चे? What you need to do? See here. We know that 1000 watt is equals to 1 kilowatt. So suppose you are having 2 kilowatts and you are being told to convert this kilowatt into watt. What you will be doing? You will be multiplying it with 2. Fine. Now children, 1 megawatt. 1 megawatt is equals to how many watt? 10 raised to power 6 watt. And similarly, the last category that comes here is that 1 horsepower. Sometimes we say no, that we are using 2 horsepower electricity, fine. So what exactly the horsepower means? it is also this quantity what we are using here, that 1 horsepower is equals to this much watt, that is 746. So if somebody is telling you that you are using 1 horsepower, this means that is 746, that means 746 watt is being used here. Fine children, so I hope this thing is clear. Now see, if question comes in your paper that what do you mean by the average power, so what is average power? See, the total energy that is consumed, fine, whatever the energy, suppose you are doing something, obviously your body might be having some energy now. Until unless your body will not be having energy, you are unable to do the task that is being given to you, fine, and you need to divide this thing with time, fine. This is what we call it as average power. Now here comes some numerical portion. I want everybody to sit with the notebook and take out one pen and start solving the numerical portion. See, the question says a boy does 400 joule of work in this much second. So always remember this thing, whatever is given in your question, try to write it down first in your notebook. Like you know that work done by the boy is 400 joule. So firstly we'll be just go through the question only. So a boy does 400 joule of work in 20 seconds, fine, and then he does 100 joule of work in 2 seconds. We are being told to find out the ratio of the power delivered by the boy in both the cases. Fine children, so we are having 2 cases here. It means we'll be having W1, T1 and P1. Similarly, talking about the second case, that is W2, T2 and P2. Fine. So now what we are going to do here, time is given to you, power is not given to you, and work done is given to you in the first case. Fine children. Similarly, when we are talking about the second case, so here W2 is given, T2 is given and P2 is not given. Fine. So we just have to simply apply the formula, and the formula is power is equals to work done upon time. Okay? Abhi what you need to do? You just need to divide both the things. Why? Because we are being told in the question, we are being asked that find the ratio. So ratio you all know, but we need to divide the things, whatever is being given to us. So we need to divide both the powers. So how you will be calculating the power? First of all, we need to know the power 1, power 2. Fine. So power 1 is W1 upon T1. Just put the values into your given formula. That becomes 400 divided by 20 and your answers comes out to be 20 watt. Fine children. Now, similarly you can do the power 2 also. How will be calculating the P2? By dividing the work done of the second case and with the time that is given in the second case. That becomes 100 upon 2 and your answers comes out to be 50 watt. Now children, see, both the powers has been calculated. So what we need to do? You just simply put the values in P1 upon P2 and your answers comes out to be 2:5 ratio. Fine. So this is what the question is and you need to do it. Now the second question is, the heart does this much of work in each heartbeat. How many times per minute does it beat if its power is 2 watt? So in the question, what things are given to us? See, work done is given, that is 1.2 joule. Time is given 1 minute. You just need to convert 1 minute into second. And you know how we'll be converting it. 1 minute is equals to 60 seconds. Power is given to us, that is 2 joule per second, because it is given 2 watt. And we have studied na bache, how to convert watt into joule second. So 1 watt is equals to 1 joule per second. So 2 watt is equals to 2 joule per second. Fine. Now simply apply the formula, that is work done is equals to power into time. Power is given to us, time is also given to us, and your answers comes out to be 120 joule. Now see children, the question may, what the question is saying to us, how many times per minute does it beat, right? So it means number of times heart beats per minute. We need to find out this thing. Okay, ab dekho. So how you will be calculating it? Simply apply the formula, that is total work done divided by work done in each heartbeat, and that is total work done is 120. Okay, and what about the work done in each heartbeat? That is 1.2. So your answers comes out to be 100 times. Fine. So this was the most, I think the questions that I am giving you bache, they are not that much, because what I am thinking that we should do from easy to complex. Okay. So the first one was easy, this one is little bit tricky, and now comes the last thing, that is commercial unit of energy. It is also the same. Okay. Now we know na every unit is expressed in larger quantity. So here the unit joule is too small to express large quantity of energy conveniently. So what we have to do? Therefore, a bigger unit of energy is used, and that is kilowatt hour, or we can also say it as board of trade. Okay? Now 1 kilowatt hour is equals to how many watt बच्चे? How many joule? See, first of all 1 kilowatt hour. So 1 kilowatt into 1 hour. What is 1 kilowatt? Is equals to how many watt? 1000 watt. And what about 1 hour? 3600 seconds. So simply multiply 1000 joule per second with 3600 second, and we have got the answer, that is 3.6 into 10 raised to power 6 joule. Fine, children? So this was your concept. Similarly, we'll be doing one numerical here. An electric bulb of 80 watt is used for 8 hours per day. We need to calculate the units of energy consumed in 1 day by that bulb. Okay? So see here, the power of electric bulb is given to us, that is 80 watt. If we need to convert it into kilowatt, then it becomes 0.08. Okay, बच्चे? Time is given to us. So how will we calculating the energy? Simple, बच्चे. We just need to apply the formula, that is energy is equals to power into time. After applying the formula, we have got the answer, that is 0.64 units. Fine, children? This question I will be discussing with you in your online session. Fine? This thing is also exactly the same. Alright, children. Thank you, everyone. See, in this question also you have to do the same thing. Remember, the same unit has to be here also. How many electrical units are consumed each day? So for every day you need to calculate it. So what you need to do? Power into time, everywhere the same thing has been done. Okay? Alright, children. Thank you, everyone.